All right, our problem is a 60 kilogram block is pulled by a 300 Newton force at an angle of 30 degrees to the horizontal. The coefficient of kinetic friction is 0.3 between the box and the surface. We're gonna draw a force diagram for the box and then find the acceleration of the box and the normal force. So let's lay out what we know first. We know the mass of our box is 60 kilograms. We know the force of tension is 300 newtons. We know theta is 30 degrees, and we know the coefficient of friction is 0.3. So when we draw our force diagram, we have force of gravity acting down, and then we have the tension force acting at an angle of 30 degrees with the horizontal. And then since tension is not directly up or down, we're gonna break it into components. This is 30 degrees here, and this is Ftx and Fty. Then we draw our normal force. I'm gonna draw my normal force smaller than the force of gravity because we know that the forces are balanced in the y direction. The object is not accelerating up and down. So that means that my total force up has to equal my total force down. And since we have this tension y acting with normal to counteract gravity, normal is going to be smaller than gravity. And then we have a frictional force, and we're looking for the acceleration. So I'm going to assume the frictional force is smaller than the force of tension in the x direction, and I'm going to draw it smaller. Our next step is to write net force equations for the x direction and the y direction. Set positive directions. Let's see. Since it's accelerating to the left, I'm going to set to the left and up as positive. All right, so sum of the forces in the x direction. We have the force of tension in the x direction plus the force of friction. And then we have sum of the forces in the y direction, and that's normal force plus force of tension in the y direction plus force of gravity. Now we're going to set our equations equal to MA. Actually, before I do that, I'm going to solve this triangle here. So Ftx is going to be equal to force of tension times the cosine of 30 degrees. And we know our force of tension is 300. So 300 times the cosine of 30 degrees. And make sure you're in degrees on your calculator. So that is 259. I'm going to round it to 260. 260 newtons. And then Fty is equal to 300 times the sine of 30, which we don't really need to do on our calculator because we know that it's just half. But some of you like to use your calculator no matter what, just to double check yourself. Okay, so then we have 150 and 260. Now here's where we have to stop and apply our positive and negative direction. My Ftx is in the positive direction, so that's going to be positive 260, and my Fty is also in the positive direction, so it's going to be positive 150 when I plug them in. Now up here, I know it's accelerating the x direction, so I'm going to put MA here. And then Ftx, I'm going to leave this in variables for right now. And then plus my force of friction, and force of friction is mu times the normal force. Now, I don't know what the normal force is, so I can't solve for acceleration. So in these problems, usually you're going to have to solve for normal force first before you solve for acceleration. So let's go over to the y direction equation and solve for normal force, and then we'll plug it into the x direction equation. I know my net force in the x direction is 0 because acceleration is 0, and so that's equal to normal force plus Fty, which I solved for, plus mg, and we're looking for the mass of the box. We have that, we know g, and so we can solve. So let's isolate normal force. So normal force is negative Fty minus mg. All right, so now we're going to plug in numbers. My FTY is 150. And then I'm subtracting mg, so my mass is 60. And then we have to decide, my g is a vector, so I have to decide if it's positive or negative. Gravity is acting down, which is negative on my, in my system, so I'm going to put negative 9.8. I kind of ran out of room here on my paper, and that's newtons per kilogram. So then I'm going to calculate my normal force here, and we get negative 150 minus 60 times negative 9.8. And that gives me 438 newtons. And it's a positive, which makes sense because up is positive and normal force is positive. So there is my normal force. Now I need to solve for the acceleration. And so I'm going to use this equation. I'm going to bring it down here so I have some more room to solve for acceleration. I'm going to isolate acceleration by doing acceleration equals ftx plus mu times the normal force over mass. And I have ftx, I have mu, I have normal force, and I have mass. So now I just plug them in. My ftx is 260, and that's positive because it's acting in the positive direction. And then my mu is 0.3. My normal force is 438 newtons. And then I divide by my mass, which is 60 kilograms. So we get, let's see here, 260 plus 0.3 times 438 divided by 60. And we get 6.5. That's very quick acceleration. I guess we could put a 2 there. Meters per second squared. Something went wrong. Aha. So this has to be negative, right? Because this is my force of friction. So that needs to be a negative value. So we're gonna redo that. I was like, that acceleration seems a little bit high. All right, 260, and then we're gonna subtract 0.3 times 438, and then divide by 60. That's much better. All right, acceleration equals 2.14 meters per second squared. It's okay to make a mistake in your calculations. Double check your work. Make sure you double check your signs. Go back and fix it if you do. This is a little bit tricky because when your force of friction is a vector, but when you plug in mu times the normal force is positive, even though force of friction is negative. So you just have to be really careful with your signs. Remember that if you keep these little vector symbols over your vectors, then that can help you because you can stop and think, what direction is this force? And it can help you remember to put a negative sign on if it's in the negative direction.